Hi, how's it going? Well, what I'm going to do in this video is look at differentiating the sine and cosine functions. Okay, so you should already know that when you differentiate y equals sine x, you get dy dx equals cosine x. And when you differentiate y equals cosine x, you get dy dx equals negative sine x. But why? Why is that happening? Let's just investigate a little bit. So graphically, what we're saying is this. When we differentiate the graph of y equals sine x, we're getting the graph of y equals cosine x. Okay, that's what's happening graphically. Now let me just show you something here. I've got a graph of y equals sine x, and this blue line represents a tangent line at a particular point. Now I'm going to run the video, and what we've got is we've got a point that is going along the sine graph, and at this particular point the tangent line is drawn out. Now why are tangent lines important? Because that's what differentiation is all about. Differentiation is about finding the gradient at a particular point on the graph, and you can visualize this using a tangent. Now notice what's happening with the tangent line. It's following a sinusoidal path. What that means is it is following the path of a sine wave. Okay, it's actually the cosine wave to be precise. Now what I'm going to do is I'm going to pause it and I'm just going to run it. Okay, and I'm going to start it here at the origin, and the tangent line here is actually at an angle of pi over 4 radians. 45 degrees. It's actually got a gradient of 1. Okay, the gradient is actually 1. Remember that. Now, if I'm just going to fast forward it to when the coordinate is pi over 2. Here we are. There we go. At x equals pi over 2. It doesn't come off nicely, does it? It's supposed to be actually flat, perfectly flat, but I can't get it perfectly flat on my thing. No. Well, just imagine it, okay? It's actually perfectly flat at the top, okay? Well, what I'm saying is the gradient at x equals pi over 2 is 0. I'm going to run it a bit more, and then the gradient becomes negative, and at this point here, when x is equal to pi, the gradient is actually negative 1. And then when it gets to this point here, the minimum point, of course, it's supposed to be a flat tangent line. Oh, almost, yeah. Doesn't come off as well in my video there, but you can imagine that the tangent line is actually flat, 0. And then when it gets to here, what's the same as its starting point at 0, it's actually gradient of 1 again. Right, let's go back to these graphs here. So, what I was saying was that at this point here, the gradient was 1. Imagine this graph here is actually our gradient function graph, and the gradient is 1. Okay? And then, at this point here, the gradient is 0. Tangent line there was horizontal. I can actually draw it as horizontal there on my graph. Okay. And that there, the gradient function represents the point where it goes to gradient is 0. And then here, the gradient was negative 1. And then here, flat again at the minimum points, the gradient was 0. And then back to here again, the gradient is going to be 1. Okay. So, gradient of 1, 0, negative 1, 0, 1. Notice here on the gradient function, when I say the gradient function, I'm saying if we plot the curve that matches the gradient at any particular point, gradient is 1, 0, negative 1, 0, 1. Okay? And you saw the tangent line, the way it goes, it follows the exact pattern of a cosine graph. Okay? Also, notice that from here to here, the gradient is always positive. It's increasing. Okay? And notice here, when the curve is above the x-axis, that means that the gradient is positive. And then between here and here, the gradient is always negative. It's decreasing, and that's why here you've seen that the gradient is below the x-axis, so it's negative. And then from here to here again, we've got an increasing function again. The gradient is positive, and that's why the curve is also above the x-axis here. So I'm hoping that makes things a little bit easier for you to comprehend. Okay. Now let's look at what's happening with the differentiation of cosine x. And I've drawn here the graph of negative sine x to show you what's going on. Now I've got another video here of cosine x. Yep, here it is. Same again, I've got the tangent line set up so that it's following a particular point on the graph of y equals cosine x. And I've got it on a loop. Okay. And what I'm going to do is I'm going to pause it, and I'm just going to run it myself. Okay. So if you just start here at the top this time, I'm trying to freeze it. Yeah, that's it. Because it's a video, it doesn't like to freeze at a precise point that I'd like it to. Okay. But you can imagine that the tangent line is just perfectly flat at the top. Okay, it's got a gradient of 0 right at the top. So when x is 0, the gradient is actually 0. And then when I play it, now at this point here, when it crosses the x-axis, when x equals pi over 2, the gradient is actually -1. And if I keep on playing it, of course, when it gets to its minimum point, the tangent line should be flat again. Oh, got it perfectly that time. Hey, great. Well, you can see that the gradient is perfectly 0. It's not perfect, is it? Because it doesn't actually, well, it's the best I can do. Okay, but the gradient is actually 0 when x equals pi. And then keep on playing it here. When x equals pi over 2, the gradient is 1. And then at the maximum point, when x equals 2 pi, can't quite get it. Oh, my video's frozen now. Well, there, you can see the gradient is going to just be 0. Well, enough of the video, let's just go back to the graphs. So, what I was saying was, here, the tangent line will be horizontal, represent the gradient of 0, which is here. And then here, the tangent line is like this, gradient is -1, which is here, -1. Here, the gradient line represents a gradient of 0, which is here. And then next is 3 pi over 2, the gradient is 1, which is here. And then finally, maximum point, again, gradient of 0 when x is 2 pi, here. So you can see the gradient function, when plotted, does actually match the path of dy dx equals negative sine of x. Now, if I just look at the function between here and here, notice that it's a decreasing function from here to here between 0 and pi. What that means is, because it's decreasing, the gradient is always going to be negative between here and here, which is why the graph is always below the x-axis when we plot the gradient function. The gradient function is always going to be negative, which is why it's always going to be below the x-axis. And then from here to here, it's a positive gradient always. It's an increasing function. And so because the gradient is positive on the gradient function graph, it's always going to be positive between pi and 2 pi. I'm hoping that's a nice demonstration for you of those rather important results. Why is the case that when you differentiate sine x, you get cosine x, and when you differentiate cosine x, you get negative sine x. It's not a proof, but it's a nice visual demonstration. Hope you enjoyed that.